Happy New Year. This is 2026 and I am usually the interviewer of this podcast and don't always get a chance to say in depth what I really think. Now, my name is Patrick Holford, and the advantage that I have over many is that since I was 19, I've been relatively obsessed with the whole subject of nutrition and nutritional medicine and the brain, and there is virtually not a day where I'm not reading a research paper. Also, what I've done since the very beginning is to find the scientists that I really rate and interview them, ask them questions, and in effect become their student. So my actual sort of qualifications appear quite thin, but the reality is I've spent what is now 47 years immersed in the subject. And a classic example of that is Dr. Linus Pauling. Now, if you've never heard of Dr. Linus Pauling, that is a bit of a shocker, because he is probably, he and Einstein were rated as the greatest scientists of the last century. And when Albert Einstein was asked, "Are you a genius?" he said, "If you want a real genius, it's Dr. Linus Pauling." His area of expertise primarily was chemistry, and he won his first Nobel Prize, the only man ever to have won two unshared Nobel Prizes, for his seminal paper on the nature of the chemical bond. So before Linus Pauling, chemists knew that if you put 2 parts of sulfur with 1 part of chlorine, or whatever it happened to be, you get sodium chloride. And then Linus Pauling, knowing that atoms, you might have seen these images of atoms, and they have a sort of nucleus in the middle and whizzy things around the outside called electrons. And he worked out how these compounds, or rather these elements, combined, the nature of the chemical bond. And that was the beginning of modern chemistry as we know it. He had 1 PhD only himself. He got awarded 47, so he ended up with 48 PhDs, quite extraordinary. And he actually missed a number of Nobel Prizes. His second Nobel Prize was for peace, when he campaigned against nuclear bomb testing, which is with Einstein, and then after Einstein died, he continued this. And when the treaty to ban nuclear bomb testing internationally was signed, he got his second Nobel Prize. We're in the McCarthy era, and he got grounded. He got sort of labelled as a communist, and his passport was confiscated. And he wanted to get to Oxford University, where a French scientist, Madeleine, was doing experiments. This is in relation to the nature of DNA. And if you saw the absolutely brilliant film Oppenheimer, where suddenly there are all these theoretical physicists, but you've got to run experiments to sort of test if the theories are correct. This Madeleine was doing the experiment, and Pauling wanted to get there. And Watson and Crick, Francis Crick, who won the Nobel Prize for DNA. And by the way, Francis Crick, who died recently, and also took acid, LSD, and that's where he got his breakthrough. That's actually what happened. They were paranoid that if Pauling got hold of Madeleine's data, he'd beat them to it, so he couldn't leave the country. He was grounded. He guessed a triple helix, not a double helix, and thus narrowly lost the next Nobel Prize for DNA. He then worked out how genes cause disease, so that was his work, a phenomenal piece of work, and later epigenetics, how the environment affects genes. I mean, really an incredible scientist. And we now know all about vitamin C because of Linus Pauling, but we don't perhaps appreciate the genius of his thinking, which is very simple. And he told me shortly before he died, I filmed him a few months before he died when he was working on his theory of lipoprotein A for cardiovascular disease, which is terribly important. And he looked me in the eye and he said, "Patrick, follow the logic. It's the logic that counts. It's the science that counts." But he said, "Don't worry too much about the randomized controlled trials. They come later." And I've learned in life, you follow the logic, you get to the truth. You follow the money, you realize, why things are very, very skewed. But his logic was very simple. All animals make vitamin C, except for very few. Primates don't. Guinea pigs don't. That's why they're the experimental animal of choice. Bats don't, or most bats. And those animals that don't make vitamin C are very susceptible to viruses, as well as cancer and heart disease. So he looked at how much vitamin C an animal that makes vitamin C produces when under viral attack. And rats make less than goats, but they make a lot. And he did the chemistry on it and worked backwards and said, basically, we need to be taking 1 gram of vitamin C an hour when under viral attack to get the blood level to the same as that which occurs in animals who make vitamin C. So all you're doing there is you're sort of copying the physiology of animals that make vitamin C. We think that we lost the ability to make vitamin C somewhere in our distant sort of past, where some primate or monkey, actually, because they both don't make vitamin C, maybe had a little bit of radiation that knocked out a little bit of genetic code, because genes make things and they make enzymes, and there's one enzyme called GOLO, G-O-L-O, which we lack. We don't actually lack the whole gene for the enzyme. We lack a small part of code called a codon, and consequently we cannot convert glucose, which is what animals convert, into vitamin C. Would that have been a disadvantage? Possibly not, because this was a time when our distant ancestors were living in a tropical fruit-rich environment. A gorilla will eat 4.5 grams a day. No self-respecting monkey eats under 1 gram a day. I'm talking from leaves and berries and roots and fruits and so on. And so if you didn't need to make it, you didn't need to use all this glucose to make vitamin C, then you'd have more glucose, you'd have more energy, and probably that particular individual becomes top shagger, so to speak, extra energy, more power. They're the dominant alpha. And eventually, the whole, we end up with, we're all descended from that. We can't make vitamin C. So that was his simple logic. We don't make vitamin C. How much do animals make who do? Why is it that those animals don't have so much risk of virus, cancer, heart disease? And that was the last 38 years of his research. Also, what happens, plants make vitamin C from fructose, while animals do it from glucose. So they're all making vitamin C. And I've long thought that vitamin C, which is a very powerful antioxidant, in other words, it mops up the exhaust fumes of turning glucose or fructose into energy, which is done inside our cells, inside our mitochondria. So we have this little sort of nuclear factory that is generating all this energy and exhaust fumes. And I've long thought that vitamin C had to be there from the very beginning. In other words, you can't have the factory making energy with this byproduct of exhaust, of oxidants, without having the antioxidant. So it's kind of as old as oxygen-based metabolism is, and it occurs in all life forms, that produce oxygen, produce energy through this reaction of glucose with oxygen. So it's kind of really, really, really deep. And this is such an amazing piece of logical thinking. I mean, nobody before then had any idea that if you took very high dose vitamin C, when under viral attack, every hour until the virus has gone, because no virus can survive in a high vitamin C rich environment. I mean, this is really, really important. I remember, and how tragic was this, back in the days of AIDS and HIV, when Linus Pauling, together with the brilliant immunologist Dr. Raksit Jariwala, took human cells, infected them with HIV, had previously exposed them to a high vitamin C rich environment and proven that the vitamin C was non-toxic to cells in very, very high levels. And anyway, infected these cells with HIV, exposed them to a high vitamin C environment, and they in effect eradicated the virus by 99.8%, measuring something called reverse transcriptase, and then compared it to AZT, which was the leading anti-AIDS drug at the time. And it was many, many, many times more effective. And the consequence of that genius work published in the Proceeding of National Academy of Sciences led to many years campaigning and finally achieving a multi-million-dollar budget to run a clinical trial in many different research centers on high-dose vitamin C in people, HIV positive. And the tragedy was a few months before that was due to run, the money was pulled and put into drugs. Surprise, surprise. Vitamin C being dirt cheap, the drugs being patentable and therefore very expensive and therefore very profitable. So that line of research got blocked. And interestingly for me, I wrote about this in my book, The Optimum Nutrition Bible, in a very broad sense, in basically a chapter saying, do we strengthen the terrain, boost the immune system, which is a theme I'm going to come to, or just look at killing, the agent. It's a bit like cancer. Do we just kill the agent, chop it out, burn it out, drug it out, or do we look at how cancer developed in the first place? So I was writing a chapter on that, and I mentioned that vitamin C had outperformed AZT. And yes, I got attacked by a journalist because when they looked up the reference, they found the first one showing that vitamin C inactivated the virus by 99.8%. And I hadn't put the second study that compared it directly with AZT, and that started a whole big, big situation that I had to deal with. That ended up in actually all sorts of trouble, legal action, and I was actually at that time I was being followed and photographed and vilified. It's very interesting. Anyway, that's not what this is about, but it makes me very, very sad when I see reasonably intelligent sort of leaders in the medical establishment and nutritional establishment who still do not understand that the power of vitamin C is very high dose upon infection. I was reading something Tim Spector, wrote about that because he'd done a survey in Zoe where he'd asked people if they took vitamin C or not. And he didn't ask about dose or anything like that. And he didn't ask about whether they took it upon infection. And he found that there was no statistically significant difference in those getting COVID who did or didn't take vitamin C, which is really a stupid question because it's not, taking vitamin C every day will not stop you picking up a virus from someone else. It doesn't do that. In much the same way, by the way, that having a flu jab will not stop you getting flu. What happens is if your blood level of vitamin C is high enough, you will recover faster. And similarly, the flu jab, if it happens to have included something that is sufficiently similar to the flu that you've just been infected with, it will speed up your body's ability to gear up its own natural immune defenses. So the power of vitamin C is primarily on taking very, very high doses. Not a gram, a day, but actually a gram an hour or 2 grams every 2 hours, which is pretty much what all scientists recommend. And in the context of COVID, it was the Chinese who knew a lot more about vitamin C than us, who ran the first randomized controlled trial in Wuhan, giving 24 grams over 24 hours of intravenous vitamin C, and they cut the mortality rate by 73%. So, ask the wrong question and you get the wrong answer. Another classic example of that going back many years, I remember meeting Dr. Chris Van Tulken in the House of Lords. We were there for campaigning about opioid addiction. It was quite funny, really, because I remember him saying, "Are you a vaccine denier?" And I looked him in the eye and said, "Are you a vaccine damage denier?" And the conversation kind of changed. But in this particular bit of telly, what they did was to take 2 grams of vitamin C, or he did, and then collect the urine over the next, 24 or 48 hours, and found that he almost eliminated 2 grams of vitamin C. And quid pro quo, it's a waste of time. Now, of course, if he drunk 2 liters of water and collected his urine, he would have excreted almost 2 liters of water, a little bit in sweat. And if he took, 2 grams of calcium, the same thing would occur. So it's a really, really, really stupid example because vitamin C in its fully loaded form is called ascorbic acid. And when you've spent it doing all this antioxidation, it becomes dihydroascorbic acid. So what you have to measure in the urine is how much dihydroascorbic acid is there, because if it had all been converted, then that vitamin C would have been used, but you'd still measure the vitamin C because it doesn't store in the body, so it's got to go somewhere. So you do get these stupid things where people really are not following the logic. And that's what Linus Pauling taught me. And what I really like is the 3 words, what causes that? That's kind of the way it goes. Like if someone says you have heart disease or have high cholesterol or whatever it is, you say, what causes that? Anyway, we'll come on to that in a minute. Now, in the area of antioxidants, there's a few things that are going to happen this year. Number one, there's a massively forgotten and fascinatingly interesting antioxidant called ergothioneine. And it is clearly part of our evolution. It occurs naturally and bacteria make it. It occurs in fungi, so it's very rich in things like porcini and lion's mane and so on. So basically, if you consider in our evolution that we have been eating, things from the earth that are dirty, that contain fungi and bacteria and so on, it's been around us all the time, and the human body doesn't make it, but it does very exquisitely capture it and use it, and also send it to places where there is damage, oxidative damage, and that occurs whenever you have an injury or inflammation or that sort of thing. So ergothioneine, it's very rare. Back in the 80s and the 90s and so on, we were actually discovering nutrients and discovering things. I was there at the discovery of antioxidants, and zinc. One of my teachers really put zinc on the map, and coenzyme Q and all these things were not heard of. So we haven't really had a new nutrient, so to speak, or a new antioxidant for a while. And ergothioneine just is one. It just happens to have very good research, but kind of got left out. So I'm going to interview Professor Barry Halliwell, who's the world leading expert on that, in the coming months. And also last year I went to visit Kaneka and the scientists there in Japan, who have done brilliant work on ubiquinol. Ubiquinol is the activated coenzyme Q. Now, we could say it's 10 times more effective than coenzyme Q. And I'm going to be giving a webinar on antioxidants. And in that, you'll see that there is this network of antioxidants that are absolutely vital, and they work together. And I'm going to talk a lot about glutathione, which is the intracellular antioxidant par excellence. It's really, really, really important. Vitamin C and glutathione have this synergistic relationship, which is also present in plants. So it's both in plants and in humans, and it's absolutely essential. And that was the reason with Dr. Konrad Kowalski, a brilliant chemist, analytical chemist. We developed at Food for the Brain the world's first measure of glutathione status based on your actual glutathione, which you can think of as the water in the fire truck that's going to put out the fire, divided by the spent glutathione, which is called GSSG. GSH is the loaded glutathione, GSSG is the spent glutathione, which is like the steam, after the fire, so to speak. And that ratio, which we call the glutathione index, is a fairly exquisite way of knowing your total antioxidant status. And antioxidant status is still absolutely central to the whole process of anti-aging. And it is this ubiquinol particularly that helps in the process of recycling spent glutathione. So what happens is when you've spent your glutathione power, it then has to be reloaded back to glutathione, fully loaded, and that is done by an enzyme called NAD. And NAD is based on, the N is niacin, or nicotinic acid, which is B3. So vitamin B3 is absolutely vital for making NAD, which reloads the glutathione. And then the NAD itself becomes, if you like, oxidized, and it is reloaded by ubiquinol. So you now have this cycle of vitamin C, glutathione, niacin, and coenzyme Q, but particularly ubiquinol. And there's quite a lot of hype around precursors of NAD. So the first precursor of NAD, or basically you start with niacin, which is what we all eat, and I love it. It's fantastic. It was first put on the map in a major way by Dr. Abram Hoffer, who was my other seminal teacher in the beginning, who noticed that a lack of niacin creates schizophrenia, or labeled as pellagra. Pellagra is niacin deficiency. You get the 3 Ds, dementia, diarrhea and dermatitis. And he wondered if some schizophrenics, he was the head of psychiatric research in Saskatchewan in Canada, might have an exceptionally high need for niacin. The idea that we are all we're biochemically unique. Some people need more than others. And he used high dose niacin, 2 grams or 3 grams, 2,000, 3,000 milligrams. The RDA at the time, I believe, was 18 milligrams. And he found that it reversed the symptoms of schizophrenia as well as lowering cholesterol. So you start with niacin, also called nicotinic acid, or nicotinamide. And then there are 2 sort of intermediary steps or substances called nicotinamide riboside, or NR, and another one which is mononucleotide niacin, or nicotinamide mononucleotide, NMN. So NMN or NR are nicotinamide riboside, that is, are patentable, hence profitable, and really being pushed as anti-aging substances. And it's quite good at one level because it's opened up a ton of research. I mean, who's going to fund research? And the answer is organizations who've got a patentable product. So we're learning a lot, if you like, about niacin and NAD through the chances to make loads of money from NMN or NR, which are patentable and cost a ton more than the very simple niacin, all of which raise NAD, which have the effect of being able to recycle glutathione back into its active form. And by the way, vitamin C, once it becomes spent, needs the glutathione to load it back from dihydroascorbic acid into ascorbic acid, its active form. So synergy is absolutely key. And do you need these really expensive other compounds? Possibly not. Ubiquinol is coenzyme Q, but fully loaded, so it is just 10 times more effective and not nearly that expensive. So the cost-benefit equation is really, really worth it in that regard. And talking about antioxidants, I'm also going to interview Dr. Robert Lustig, emeritus professor from the University of California, who has a whole new theory that many of the things that lead to cognitive decline, brain damage, brain disorders, dementia, and so on, have the effect of raising oxidation in the brain. So is there a common pathway that ultimately leads to this problem? And I'll touch on common pathways a bit more when I talk about the sort of front line of what's happening in relation to Alzheimer's and dementia. Now, just before we leave vitamin C, it might also be worth giving an overview. When we say follow the logic, also there is the situation of follow the money. And in case you didn't know, Big Pharma is in a very, very interesting commercial situation. There really is hardly nothing in the pipeline in terms of blockbuster drugs. You make your money by making a drug that you can give to millions and millions of people. It's a blockbuster drug. And then you get a patent for a certain number of years, maybe 20 years, but it might take you 5 years to bring the drug to market. And it costs something like $1 billion to bring a drug to market. And then you have a patent, so you can charge a lot and you can therefore spend a whole lot on marketing and sell the drug. So that's the model. Blockbuster drug given to millions with a patent and a period of time to make money, after which the patent runs out and then you kill it off. And there's virtually nothing in the pipeline. That's the problem. And one of the big untapped markets is the many, many millions of people with dementia. And if you can even diagnose dementia earlier or risk for dementia earlier, you can increase that market. You can basically make a market of people that you say are more likely to get dementia. So there's a lot of attention going into, bringing a drug to market that we can give to loads of people who have pre-dementia or could potentially have it if we test them and sort of scare them enough, so to speak. It kind of goes a bit like that. And so what's generally happened in pharma is they've worked out that they can't support their profits just with blockbuster drugs because there just aren't enough in the pipeline. And the whole Alzheimer's area, when we get onto it, has been vastly disappointing. I read somewhere an estimate of 250 billion having been spent so far on all the research, potentially leading to drugs, and we basically don't have one that works yet. I mean, it's a lot of money to get back. So the decision was made by many to move a significant amount of profit into vaccines. That was the point. So vaccines are the holy grail of the underlying source of making money in big pharma now that the blockbusters are really, really drying up and the main owners are running out of patent or have run out of patent. So that's kind of what's going on. And part of the move, it was the vaccine pitched for cervical cancer. And if you like, sold to governments and health systems to, get all young girls, I don't know why, not young boys, vaccinated, that actually won a marketing award for effectively creating a market out of almost nothing. And it provided a model for making money out of vaccines. And then, of course, COVID, we've seen a very nice model for making money out of vaccines. And part of the technology that allows for vaccines to be, which are effectively injecting something that the immune system reacts against to make it think it's got the infection. So that's the idea. And if what you inject happens to be a dead virus, but the immune system sees the virus and then recognizes it and makes a blueprint to be able to attack that virus, then that's the basis for a vaccine. And the latest technology, it was not so late, it's been around for a while now, mRNA, where you actually provide particles that trigger the immune system into thinking that it has that particular infection, is a major part of, if you like, vaccine technology. And there are plenty of scientists who are really worried about mRNA base for vaccines. And to contextualize this, after all these years, recently in the US, causing heart problems, and we're talking here about myocarditis, pericarditis, the COVID corona vaccines causing damage to heart tissue, and there's no reason why it would only be heart tissue, by the way, has now been added as a black box warning. So, it is true. It is a real concern, and there are many other concerns with mRNA vaccines. So, talking a little bit about vaccines in this context, later on I'm going to talk about Alzheimer's, because the treatments being proposed are antibody injections that attack amyloid. So what you're doing here is you're getting your immune system to attack something you wish to attack, in the same way there can be cancer vaccines where you introduce something that triggers the immune system to attack cancer. So that's a whole sort of new territory. And one of the extraordinary things about vaccines is that they just, in many cases, have not been subjected to the same science that one would expect for a drug or a vitamin. And this was, I remember talking many years ago to the brilliant GP, Dr. Richard Halverson, who had desired to become a TV doctor and spokesperson, very good scientist, very good GP. And his first assignment at the time was to investigate and report on all this bollocks that the MMR, measles, mumps and rubella vaccine might have anything at all to do with autism. And when he did, he was astounded at the lack of science. I mean, they just hadn't done studies on the danger of MMR vaccines. And the studies that had been done were just for a couple of months. I mean, basically, right back then, the vaccines had not been fully studied, and the same is true today. I mean, the astonishing thing in America, which of course is an absolute human right violation, is that children can't go to school unless they've had, whatever it is, over 50 vaccine doses. And no one has investigated properly the effects of all those put together. So the one thing you cannot mention, I mean, I don't mean you, but I mean, there's this sort of don't attack vaccines, don't go after vaccines. So vaccines is such a big profit center for Big Pharma that they are remarkably protecting the whole territory. And anyone who dares raise any question about any vaccine, is immediately silenced or labeled as some sort of, conspiracy theorist or whatever it happens to be. And that is completely wrong. So vaccines need to be subject to exactly the same science. And I am completely in support of Robert Kennedy, who basically has cleaned up in America the CDC, the Center for Disease Control, and the FDA, the Food and Drug Administration, whose boards of experts were absolutely riddled with people who had vested interests effectively in selling vaccines. So if you're going to have a group of scientists, don't have scientists who actually, one way or another, whether through shares or consultancies or whatever, are in the pay of the the drug or the vaccine that you are judging. That's terribly, terribly important. And to give you an example of how crooked the FDA had become, when one of these new anti-amyloid Alzheimer's drugs was being pitched to get a license, you have to get a license to be able to sell a drug, the 10 experts get to vote yes or no to the license. 9 voted no, 1 abstained, and the FDA still gave a license, and a number of those key top scientists, the independent experts in the board of experts, resigned, in protest. So what Robert Kennedy has done is 3 things, which I think, regardless of one's view on vaccines, is totally right. Number 1 is he's created a scientific board on the FDA and the CDC, Center for Disease Control, that are very good scientists who are not in the vested interest, not in the pay, not in the gravy train for the substances that they are due to judge. And the third thing he's doing is changing, through legal means, is changing laws such that we, individuals, parents and their children, have a right not to be injected, with a substance. In other words, mandatory vaccination, I don't think is appropriate in the same way that mandatory, taking drugs is not appropriate. So that's a little hot area that's going to keep unfolding in the US particularly. And yes, I know one of the absolute shockers, I thought, and I've never been able to quite get to the bottom of this, is basically if you have a 3-in-1 vaccine like MMR and the patent runs out, then if you just add one more agent, so it's a 4-in-1, and then when that runs out, one more agent, you can keep making shitloads of money. And GSK had one of these, combined vaccines, which they were hoping to sell into the American health system. And I know when Robert Kennedy got appointed as, in his position in the States, their share price crashed because they realized we're not going to get away with this. And I know that in one of these vaccines, they'd added a virally transmitted hepatitis that is transmitted via sex. So it's a sexually transmitted hepatitis virus that is given to, children, shortly after birth. I mean, that is totally insane. But it may not be insane if that addition then allowed for a new patent, because you've made something new, you've added something new. So I've never quite got to the bottom of that and how you extend your patent. And that's kind of the important point, is the extension of the patent to keep making money. So hopefully we'll get a little bit more proper science on vaccines unfolding, but of course it's a highly political area. So moving on to vaccines, and cancer vaccines is going to be a fascinating topic of conversation next year. I was recently looking at the effect of beans in relation to cancer. So that's an interesting little topic. And by the way, I'm reminded, if you haven't read my book, Alzheimer's Prevention is Cure, and by the way, figure 20 and figure 21 explain those interactions with antioxidants. I particularly like, and would draw your attention to, a chart at the back of the book, which kind of puts the impact of what you do into context. And this chart, which talks about what are called population attributable risks, I'm just finding it in my book, where you've gone, is quite a nice way to kind of contextualize everything that you can do. The chart's on page 173. And let me give you an example of how one line on this, on omega-3 works. We can now measure a person's omega-3 status very well. It's called the omega-3 index. And we can do it on a single drop of blood, a dry blood spot analysis. At Food for the Brain, it's part of their DRIFT, their 5-in-1 test. And it actually measures of all the fatty acids in your red blood cells, hemoglobin, it's the red stuff, what percentage is EPA and DHA. DHA is the critical structural fatty acid in the brain, and EPA converts to DPA. And if you're over 8% of your total fatty acids is EPA and DHA, then your risk for dementia is very, very low. And statistically, you don't get much additional benefit going higher and higher and higher. But if your level is below 5%, your risk is really, really high. So in this particular chart, in the first line, it says that if you are low, below 5%, so it's defined, and you increase it to over 8%, you will reduce your risk of getting dementia by 20%, which is quite significant, a fifth. And half of the population, roughly, this is based on over 50-year-olds, are below 5%. So if you gave everyone omega-3, half of them wouldn't need it, and half of them would. The half that needed it would have a 20% reduced risk. The half that didn't need it would have no reduced risk, we assume. Therefore, the average risk reduction, or what's called the population attributable risk, is 10%, so half of that 20%. So that's a very nice way of looking at things. And I'm going to give a talk and write an article on cancer in that context later on this year, because I said many years ago that you can predict a country's risk of cancer by knowing two things. One is their intake of milk and their intake of beans. And I am talking here primarily about breast and prostate cancer, in other words, the sort of hormonally related cancers. And I remember many years ago reading that the lifetime risk of breast cancer in a rural Chinese woman was 1 in 9,000, and the lifetime risk of prostate cancer in a rural Chinese man was 1 in 25,000. Now, maybe the diagnosis wasn't so, prevalent and so on. But we're at roughly a 1 in 7 lifetime risk of breast cancer in a woman and 1 in 7 lifetime risk of prostate cancer in a man. I don't know about you, but in the last year, I've just so many people I know. It may be a function of my age. I'm 67, so a lot of my friends are sort of in that age group, being diagnosed with breast cancer, being diagnosed with prostate cancer. So 1 in 7 versus 1 in 9,000, I mean, that's a big difference. And And also, by the way, when Chinese people emigrate to America, that's where most of the data is, within a generation or two, their lifetime risk becomes equivalent to that of an average American, so to speak. So in other words, it's not in the genes, not like the Chinese have different genes. It's got to be something they're doing that we're not doing, or something they're not doing that we are doing. And one of the things they do is they eat lots of beans. And beans are particularly important, and especially soya beans. And I'm talking here about what we call isoflavones. And one of the most particularly powerful isoflavone in soya is called genistein. And I actually recommend and include genistein in supplements that I suggest for women, and particularly for women who want to have a lower risk of breast cancer. It is a phytoestrogen. So a phytoestrogen means a plant-like estrogen, but it doesn't have the same effect as estrogen. It may actually work primarily, not only, as an estrogen blocker. So all the drugs that are given for someone who's got breast cancer, the like tamoxifen and the aromatase inhibitors, these are all effectively blocking estrogen receptors. Estrogen makes things grow, progesterone keeps things healthy, progest. So just to back up a little bit on this other fascinating and interesting area, that basically, all men make estrogen and progesterone. Progesterone is made from cholesterol, and from progesterone we all make estrogens, and we all make cortisol, the stress hormone, and we make testosterone and DHEA. Think of it as sort of anti-stress, so to speak. And that's kind of the way it goes. If you have too much estrogen, you get overgrowth signaling. So to contextualize that, I mentioned beans and milk. So the rural Chinese never, ever, ever had milk. They thought drinking milk was a weird thing. And in the early days, the Europeans who had arrived, they said they smelt weird due to their drinking of milk. So I say I'm 67-year-old, still breastfeeding from another species of animal. Do you think I am weird? I'm talking about consuming milk. Or I say, can you name me a mammal that consumes dairy products as an adult? And there are none. So every single species on this planet consumes its own mother's milk, which is fully loaded with growth signalers, growth promoters. That's the function of milk, to make things grow rapidly, make cells grow rapidly. Very, very important in the early stage of life, to have this rapid growth stimulated by milk. And then after a period of time, all animals stop that. And the massive growth phase is over, the milk is stopped. It's a very simple logic. And us humans who keep guzzling milk, it's good for the milk industry, but it's completely evolutionarily and physiologically and biologically illogical, to keep consuming milk. And what it does is to stimulate growth. And we know without a shadow of a doubt that if you consume dairy products, I'm not talking here about organic or cheese or yogurt, and just anything from an udder, you will raise a major growth promoter, which is called IGF-1, insulin-like growth factor, IGF. And IGF will make pre-existing cancer cells grow faster. There is no question about that at all. There is a bit more of a question as to whether milk can make a normal cell become a cancer cell. I'll talk about that in a minute. But there's no question, if you've got a breast cancer cell or a prostate cancer cell or any cancer cell, colorectal cancer cell, for example, then the more milk you have, the higher will be your IGF level, and the faster those cells will grow. So the data, and of course one of the things that's absolutely astonishingly obvious is that when you look at the rate of these cancers in Asian populations versus, if you like, Western European, American, UK populations, the odds are, the rate is completely different. And so the phytoestrogens, isoflavones, particularly genistein, especially rich in soya, actually block overestrogenization, which occurs from having too much dairy products, too much meat. And I remember when an animal is being milked, it contains estrogens and progesterones. It contains these hormones, and also being overweight because fat cells, make more estrogens. So unopposed estrogen is a standard hallmark of our current bad diet. Then if you happen to eat beans, I looked at one study, for example, where those in the top third of bean consumption, legume includes lentils and beans, had 46% lower risk of breast cancer. So almost half the lower risk. Another study found the same thing. Higher legumes, lentils, beans, 49% lower risk of cancer mortality. And another study, not so strong, those with high consumption of legumes reduced risk of developing prostate cancer by 15%. Another study in Japan, soy consumption was inversely associated with the risk of breast cancer. More soy, less breast cancer. And so on. Another study showed that the total isoflavone, so we have phytoestrogens, of which the main kind are isoflavones, of which the most important one is genistein. Those, the higher the isoflavone and genistein intake, 44% lower risk of endometrial cancer. So, in premenopausal women, higher consumption of soya isoflavones associates with 10 times fewer cases. So, these are really, really big numbers. So what I hope to do this year, and I'll only focus on breast and prostate cancer because, life is too short and there are so many cancers, is what is that risk reduction that can be achieved by just 4 very simple changes. 1 is eating more beans. 2 is having less dairy. 3 is drinking less alcohol. And 4 is having less sugar, because those are 4 major promoters of both breast and prostate cancer. If I was to add a 5th, it would be methylation. We're talking here about the absolutely fundamental process by which vitamin B6, folate, and B12 allow methylation to occur, which is how we make things in the body. It's how we turn DNA on. It's how we do that epigenetics. It's how the environment turns genes on and off through a process of methylation. The most critical nutrient of which is B12, which is very, very, very commonly deficient. About a 5th of all children have insufficient B12. And when you're older, you have less stomach acid often, and that means you can't utilize B12 because it's dependent upon stomach secretion. So probably about 70% of cancers are associated with poor methylation, which is to do with a lack of B12. And all of this sort of makes total sense, because we could not have become human, we could not have developed our high brain capacity if we had not been consuming marine foods. And marine foods, I'm talking here about mussels and oysters and shellfish and little fish and so on, is exquisitely rich in B12. It's rich in omega-3 DHA, it's rich in phospholipids, it's rich in selenium, iodine, zinc, and all the other absolutely critical nutrients. And we just don't eat those kind of foods much anymore. So many of us are B12 deficient, and we don't even know it. And then moving on a little bit to the interesting world, which I'm going to write about, of this total obsession with amyloid and p-tau. So for those who don't know, in a lot of people, but not all, with dementia, you get high levels of plaque, of amyloid plaque. Amyloid is a peptide, that's like a protein. But some people have high amyloid and no dementia, and some people have Alzheimer's and no amyloid. So it is not causative. There is no evidence that amyloid is the cause of Alzheimer's, but you dare say that these days, because so much money. There are 60,000 studies on amyloid. So there's masses of detail going into amyloid. And then the next big sort of, if you like, biological potential hallmark, but actually better, is p-tau. There is a protein called tau. It becomes phosphorylated. That turns into p-tau. And when you have p-tau, it makes nerves tangle up, neurofibrillary tangles in the brain, and having a high level of p-tau in the brain does, significantly correlate with dementia and Alzheimer's, more than amyloid. So there's a ton of work going into that, and it's an interesting little one, and I think what's really happening is that the definition of Alzheimer's is gradually being changed away from the two absolute requirements for an Alzheimer's diagnosis. One is for dementia, you have to measure a decline in cognitive function, which is what we've been doing at Food for the Brain. We've run 470,000 free cognitive function tests. So if you have poor cognitive function, you can diagnose dementia or pre-dementia, called mild cognitive impairment. But you can only diagnose Alzheimer's, which is a degeneration of a central area of the brain called the medial temporal lobe, with a brain scan. That's how you get a diagnosis of Alzheimer's. But much like we invented a disease called high cholesterol, the move is to change the diagnosis of Alzheimer's to being a high level of effectively amyloid and p-tau, but not in the brain, because you can't do cerebrospinal fluid injections, but in the blood. So I think that's what we're going to see very soon is tons of science, I put that in inverted commas, to create probably the ratio of a type of amyloid, 42, which goes down in the blood when it's high in the brain, and p-tau, a type of p-tau called 217. And this ratio will be, I think, pushed and pushed and pushed until it becomes a requirement for the diagnosis of Alzheimer's. So, if you like, forget the psychology as the critical thing, although that will still remain, I'm sure, cognitive function test. Forget the actual physiology, that is shrinking of the brain, and focus in on the biology, which is a high level of amyloid p-tau. Primarily because then you can create a drug that lowers p-tau or lowers amyloid. Much like cholesterol became, it's like almost a new disease. So you may not have angina, you may not have high blood pressure, you may not have the signs of cardiovascular disease, but you've got a high cholesterol, and therefore you need the drug to lower cholesterol. I mean, I was pitched with that despite ridiculously healthy, criteria on all fronts, but lower the cholesterol level to anything above 5 requires medication, and suddenly you've created a market. So I think this two-step dance is well underway now, that we'll have a blood test, and who controls the level that is right or not right, given to everyone over 50, and says, you're in the pipeline for dementia, therefore you must take our drug that lowers amyloid or lowers p-tau. The only problem being at the moment, well, not the only problem, is there is no drug that lowers p-tau that works, and there is no drug that lowers amyloid that works. So the antibody injections which target amyloid and do lower amyloid have not produced a clinically significant effect, with some pretty horrendous side effects experienced in at least a quarter of people given these injections. And we're talking here about brain bleeding and swelling, and in about 1 in 200 death as a consequence of that. So the drugs aren't there, but the story is emerging that there will be a blood test that says, you're in the pipeline for dementia, therefore you have a high amyloid or a high p-tau, you need to take the drug that lowers it. It's really sickening, but that is what's happening. And I just looked up 95,000 studies on cholesterol, which is not the cause of heart disease, and 60,000 already on amyloid. The other thing that's going to be very exciting next year, and I'm so looking forward to, is the launch of our head of research, Dr. Tommy Wood, Associate Professor of Neuroscience, his new book called The Stimulated Mind. And the essence there is that it's not just about nutrition. You've got to stimulate your body. If you don't do exercise, you don't build muscle. And if you don't do exercise, your muscles atrophy. And the same thing happens with your brain. You've got to be stimulating. You've got to be learning new things. Last year, my mission was to complete my paraglider training. I've actually still got an exam to do. And once that's over, my next mission is to learn to play the bass guitar. So we need to be learning all the time and exercising all the time. And it's not all about steps, but a very simple way is if you do happen to move around the place with your smartphone, mobile phone on you, it is counting your steps. And it seems that the optimal for health is 7,000 steps, and even better if those steps are on sort of, if you like, uneven ground or uphill or whatever. So whatever challenges you physically, so dancing, movement, yoga, Pilates, cycling, swimming, anything that just keeps you moving is actually stimulating your mind. So that's going to be an important appraisal of this area, the stimulated mind. And we're going to be really focusing on Tommy's work a lot in the next year. And also, just as a final note, I have actually written another book, and this will be coming out in February, and it's called 5 Health Essentials. And it looks at methylation, it looks at oxidation, antioxidants, that critical thing. It looks at fats, lipidation, that is absolutely vital. It looks at how we use sugar, which I call glycation. And it looks at digestion and the microbiome and all things to do with that. So that will, conceptualize what I think are the 5 main drivers of disease. So finally, I wish you a fantastically healthy and happy 2026, and look forward to meeting you at events, webinars and seminars and retreats, and through my books and also through my podcasts. Very best wishes.